What is AWS? Chapter 1 introduces AWS as a cloud platform, but more importantly as an operating model for building, running, securing, and evolving modern systems. AWS, Amazon Web Services, is a large collection of cloud services for compute, storage, databases, networking, security, analytics, integration, machine learning, deployment, and operations. At the simplest level, it lets teams run systems without owning the physical infrastructure underneath. But for an architect, that description is too small. AWS is not just remote servers. It is a platform where infrastructure, managed services, automation, identity, observability, governance, and cost control become part of the architecture itself. The shift matters because traditional infrastructure often starts with capacity planning, procurement, installation, and long-lived environments. AWS changes that model. Teams can provision resources on demand, scale them up or down, replace them when needed, and automate much of the lifecycle. That makes delivery faster, but it also changes the kind of discipline required. In the cloud, bad decisions are easy to make quickly. A poorly designed network, an over-permissive identity model, missing logs, or uncontrolled cost can spread across an environment faster than in a slower traditional setup. AWS exists because modern systems need speed, elasticity, global reach, and managed operational building blocks. A team can deploy applications close to users, store data durably, process events, expose APIs, run containers, query data lakes, automate deployments, and monitor workloads using services that already exist. The value is not that every system becomes simple. The value is that teams can spend less effort on undifferentiated infrastructure work and more effort on the system they are actually building. A useful way to understand AWS is through the spectrum from infrastructure services to managed services. EC2, VPC, and EBS are closer to traditional infrastructure. They give a lot of control, but they also leave more operational responsibility with the team. Services like S3, DynamoDB, SQS, Lambda, Athena, CloudWatch, and EventBridge remove more of the infrastructure burden. They still require good design, but the platform handles more scaling, availability, patching, and service operation underneath. This leads directly to the shared responsibility model. AWS is responsible for the security and operation of the cloud, the physical data centers, global infrastructure, hardware, and managed service foundation. The customer is responsible for what they build in the cloud: data, identities, access policies, network exposure, application logic, encryption choices, monitoring, backup configuration, and many operational decisions. That distinction is central. Moving to AWS does not automatically make a workload secure, resilient, or cost-effective. It gives strong tools, but the architecture still has to use them correctly. AWS applies well when organizations need scalable platforms, faster delivery, managed services, global infrastructure, disaster recovery options, strong automation, and repeatable environments. It is especially powerful for back-end systems, integration platforms, analytics, event-driven workloads, modern application hosting, regulated enterprise platforms, and migration programs where old infrastructure models are too slow or too manual. But AWS is not automatically the right answer to every problem. If a team lacks ownership, governance, observability, cost awareness, or deployment discipline, AWS can amplify the mess. Resources may be created manually and forgotten. Permissions may become too broad. Logs may be missing. Data may be exposed. Costs may grow without a clear owner. Cloud does not remove engineering discipline. It makes discipline more important because the platform is dynamic and programmable. For senior engineers, the first principle is that AWS services are not the architecture. They are building blocks. The architecture is the way those services are combined around workload requirements, data flow, failure behavior, security boundaries, ownership, and operational reality. A service list is not enough. A good design explains why the workload uses a given compute model, where state lives, how traffic enters, how identities are controlled, how failure is contained, how changes are deployed, how activity is observed, and how cost is managed. This course treats AWS from that architectural angle. We will look at global infrastructure, accounts, networking, compute, storage, databases, analytics, integration, security, deployment, observability, cost, migration, reliability, and governance. The goal is not to memorize every AWS service. The goal is to understand the mainstream services deeply enough to design systems that are secure, scalable, operable, and economically sane. A senior engineer should remember this. AWS is a powerful platform, but it rewards clarity. Start with the workload. Understand the data. Define the boundaries. Choose managed services where they reduce undifferentiated work. Automate repeatable decisions. Observe everything that matters. Control cost from the beginning. Design for failure before failure arrives. That is the mindset that turns AWS from a collection of services into a serious architecture platform.